Logistic function. The number C is called the carrying capacity for growth models because the value PT approaches C as T approaches infinity. Given below is the typical logistic function and the graph that represents the function. So PT equals C over 1 plus AE to the negative BT. So below on the left and right, we have the graphs of the logistic growth and logistic decay. So let's talk about the logistic growth here. So for instance, this B is greater than 0 here. So this B here being greater than 0 would mean this piece right here, as T goes to infinity, that would go to 0. So you can see why if my T continues to go towards infinity, that I would approach this C, because that's going to give me that C over 1, which is C. So that's that carrying capacity that we see above here, because this would be a logistic growth. So we also have a logistic decay, where as it increases, it's going down to 0 down here. And when we talk about going to a certain number, we're talking about the y values of these functions. So this y value here is going to 6. This y value here is going to 0 as both t goes to infinity. And notice the other thing for the logistic decay, that my b is less than 0. So that means that would make this whole top positive. And if that whole top is positive, and as my t goes to infinity, this is going to grow exponentially on the bottom. So that's going to go to infinity. So as this goes to infinity on the bottom, c is some fixed number, so that means I would go to 0. So it just makes sense where that all comes from. So now let's take a look at the problem associated with this logistic function. So after the Challenger disaster in 1986, a study was made of 23 launches that preceded the fatal flight. A mathematical model was developed involving the relationship between the Fahrenheit temperature X around the O-rings and the number Y of eroded or leaky O-rings. The model stated that Y equals 6 over 1 plus E to the negative quantity 5.085 minus 0.1156x, where the number 6 indicates the 6 primary O-rings on the spacecraft. So now if we look at this first example here, number A, it says, what is the predicted number of eroded leaky primary O-rings at a temperature of 100 degrees Fahrenheit? Now again, that just simply means what I'm going to do here is just plug in 100 in for X here. So in doing that, once I plug that all in, I get this number here, which this tells me almost no O-rings are leaky or eroded, because that's almost 0. So then for the next one here, so that tells me here when I plug in 100, I get such a small number there. So now I'm going to plug in 30. Now that 30 is going to go where X is at. And that gives me 0.500628865. So that tells me there are over 5 O-rings, or about 5 O-rings, are eroded or leaky. So this tells me if we had this information before the Challenger, that could have saved that explosion that happened with the Challenger. So using these logistic models does have a realistic application. And most of these functions that we use, the exponential decay and growth, all of those are used in real life examples. So it's just interesting to see this. So there's my answers.